A single threaded 25 mm power screw is 25 mm in diameter with a pitch of 5 mm. So we have to take this value of 25 mm is equal to DO and pitch is equal to 5 mm. So from this we can calculate the mean diameter, which is DO minus P by 2. So we have given here the single start thread or single thread, therefore we have pitch is same as equal to lead. So for single start we have lead is same as equal to pitch is equal to 5 mm. Outer diameter DO is given as 25 mm. So we have mean diameter is DO minus pitch divided by 2. That is, we have DO is equal to 25 minus 5 by 2. So in this case mean diameter will be equal to 22.5 mm. The vertical load on the screw reaches a maximum value of 5 kN. So value of W is given is equal to 5000 Newton. The coefficient of friction are 0.06 for the collar. So we have given the value of mu c equal to 0.06. 0.09 for the thread. So we have value of mu equal to 0.09. The frictional diameter of the collar is 45 mm. So mean diameter of the collar is given as 45 mm. Therefore, we have radius of the collar at which the friction force will act is 45 divided by 2. That equal to 22.5 mm. We want to find out here the overall efficiency, that is eta we want to find out. Then the torque required to raise the load, that is value of TR we have to find out. And the value of the torque required to lower the load TL we have to find out. From the given right angle triangle we can calculate lambda. If we take a tan, it's opposite upon adjacent. So we have tan of lambda is pitch divided by pi multiplied by dm. So this one is same as equal to lead also. We have value of the pitch is equal to 5 mm divided by pi multiplied by dm. Dm we have to take as 22.5. Take tan inverse and find out the value of lambda. So approximately we'll get the value of lambda equal to 4.05 degree. We know that tan of phi is same as equal to coefficient of friction for thread. So we have phi is equal to tan inverse of mu, and the value of mu is given as 0.09. So we'll get the value of phi equal to 5.15 degree. Since here phi is greater than lambda, we have a condition of self-locking. That is, the value of TL will be positive value. First we will find out here how much torque is required to raise the load, which is given as the load W multiplied by dm by 2 multiplied by tan of phi plus lambda plus mu c into RC into W. So we have W is common here, so that will write as 5000 into dm by 2. Dm by 2 is same as 22.5 divided by 2. 22.5 divided by 2 into tan of phi plus lambda. We have phi value is 5.15 and we have lambda value is equal to 4.05 plus we have mu c which is equal to 0.06 into RC. RC is equal to 22.5. So in one step we will find out here the total torque required to raise the load. So the torque required to raise the load will be equal to 15860.5 Newton mm. That is same as 15.86 Newton meter. The only difference in the calculation of the torque required to lower the end in the formula of tan of phi plus lambda. Instead of tan of phi plus lambda, you have to take as tan of phi minus lambda. Rest value will remain same, equal to W. W is same as equal to 5000. So to just copy down this 5000 into 22.5 divided by 2 into tan of value of phi is 5.15 minus lambda is 4.05 plus we have collar friction coefficient is 0.06 multiplied by RC equal to 22.5. W already taken common. So torque required to lower the load is 7830 Newton mm. So very low value is required to lower the load is equal to 7.83 Newton meter. As far as the efficiency is considered, efficiency is given as W into L divided by 2 pi multiplied by total torque T. Which one is torque required to raise the load? So we have efficiency is equal to W into L divided by 2 pi times T. We have W is same as equal to 5000. Value of L is same as equal to pitch is equal to 5. So numerator is Newton mm divided by 2 pi and we have torque required to raise the load in Newton mm is 15860. 15860.5, which one is also Newton mm, and multiply by 100. We'll give the answer in percentage. Approximately this value is close to 25.1%. We'll take here one practice numerical in which we want to calculate the torque required to raise or the lower the load in case of single thread and the double thread. In addition to this, we want to compare the overall efficiency for single thread and double thread. So we have given here one power screw with the outer diameter is 25 mm with a pitch equal to 5 mm. A vertical load on the screw reaches a maximum value of 3 kN. Coefficient of friction is 0.04 for the collar and 0.09 for the thread. So this data is common to both for single thread as well as double thread. In addition to that, the frictional diameter of the collar, that is the mean value of collar diameter, is given as 33 mm. So we have to solve this for single thread and double thread. So we'll solve it for single thread first. As far as the single start is considered, we have lead is same as equal to pitch is equal to 5 mm. We are given the outer diameter equal to 25. From this we can calculate the value of mean diameter is DO minus pitch by 2. That will be equal to 25 minus 5 by 2, which is same as equal to 22.5 mm. The vertical load is given as 3 kilonewton. So we have W equal to 3 kilonewton, that is 3000 Newton. Coefficient of friction for collar is given as 0.04 and for screw is given as 0.09. The mean diameter of the collar is given as 33 mm. So radius of the collar, that is the mean radius of the collar, will be diameter divided by 2. 33 divided by 2 is same as 16.5 mm. First we calculate here the value of lambda, which is same as equal to tan of lambda is L divided by pi dm. This time we have lead is equal to 5 mm divided by pi divided by dm, and we have dm equal to 22.5. Take tan inverse and find out the value of lambda. So we get the value of lambda is close to 4.05. Tan phi is same as equal to mu, so we can take a tan inverse to find out the value of phi. So we have phi is equal to tan inverse of mu. Mu is given as 0.09. So this value of phi will be equal to 5.14. The torque required to raise the load is TR is equal to W into dm by 2 into tan of phi plus lambda plus mu c into RC into W. Almost everything is known. W can be taken common here. We have W is same as equal to 3000 into dm by 2. dm by 2 is 22.5 divided by 2 into tan of phi. Value of phi is 5.14 plus lambda. Lambda is 4.05 plus mu c, which is equal to 0.04 multiplied by RC is equal to 16.5. W already taken common. So we get the torque required to raise the load is close to 7440 Newton mm. That is equal to 7.4 Newton meter. Similarly, we can calculate here the torque required to lower the load. Instead of 5 plus lambda, it will be equal to 5 minus lambda. Rest everything is remain same. So we have torque required to lower the load is W into dm by 2 into tan of 5 minus lambda, plus we have mu c into rc into W. W again taken common, dm is 22.5 divided by 2, tan of pi is 5.14, lambda equal to 4.05, mu c equal to 0.04, rc equal to 16.5. So the torque required to lower the load in the case of single start is come out to be 2622.1 Newton mm. That equal to 2.622 Newton meter. And one more term we required is the efficiency term. Efficiency is same as equal to W into L divided by 2 pi divided by torque required to raise the load. We have value of W is same as equal to 3000. This time we have lead L is equal to 5 mm divided by 2 pi, and we'll use the value of TR in Newton mm is 7440, and you can multiply by 100 to find out efficiency in percentage. So efficiency will get equal to 32.08%. In the case of double start, lead will be same as equal to 2 times of pitch. That is, we have 2 times of pitch, 2 into 5 equal to 10 mm. The value of dm depends on pitch, so that will not change. W will not change, mu c will not change, mu will not change, even the color dimension will not change. But since the lead has been changed, the value of lambda will change. So this time we have tan of lambda, which is defined as lead divided by pi dm, and we have lead this time is equal to 10 divided by pi, and the mean diameter is same as 22.5. Solve this, you will get the value of lambda. We'll call this one as lambda 1. So we get the value of lambda 1 equal to 8.05 degree. Again you have to calculate TR, TL and the efficiency. So we have torque required to raise the load in the case of double start is W into dm by 2 into tan of 5 plus lambda 1. 5 will not change. Plus we have mu c into rc into W. Again we can take out here W common, which is equal to 3000. dm value is 22.5 divided by 2 into tan of 5. So we have value of phi is equal to 5.14, and lambda 1 you have to use as 8.05, plus we have mu c, which is equal to 0.04 multiplied by rc is equal to 16.5. Check this value is come out to be 10.169. that will be Newton meter. So I divided this answer by 1000, I get this value equal to 10.169. In the case of single start, we have 7.4. So when we use the double start, we find here that the torque required to raise the load has been increased. That is the one observation. Similarly, we can calculate the value of TL, that is the torque required to lower the load. So we have TL1 is equal to W into dm by 2, almost same equation. Instead of plus sign, we have to use the minus sign. Again substitute and find out the value of TL1. We have 3000 into dm by 2 is 22.5 divided by 2 into tan of value of phi, this time is lower. So if do not use the color, then the value of TL1 can be negative here. That is a chance of no self-locking. But this time we have phi is equal to 5.14. Lambda 1 is 8.05. Plus we have mu c, which is equal to 0.04. into 16.5. So naturally, because of this negative sign, we are expecting here, we are getting the lower value of torque. This answer will Newton mm. I will divide by 1000 and I will calculate the value of TL1. So after dividing, I will get this answer equal to 0.264 Newton meter. Now, as far as the torque required to lower the load in the case of single start is 2.62 Newton mm, and in this case the torque required to lower the load is 0.264, so that quantity decreases. And finally we can compare the efficiency also. So efficiency in the case of double start will be same as equal to W into L divided by 2 pi into torque required to raise the load. We have W is same as equal to 3000. This time we have to take the lead. L is equal to 10 divided by 2 pi, and we have torque required to raise the load. You have to take in Newton mm is 10169, is almost equal to 46.95. What you observed here is that this value of the efficiency has been increased in the double start. The only disadvantage in the double start is that the torque required to raise the load has been increased. That is not desired. Actually, whenever we have to lift the load, then we should require the lower torque. So single start is better in case of lifting the load, but as far as the TL and the efficiency is considered, the double start is superior as compared to the single start. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.